Let us solve this question next. The question says using cofactors of elements of third column. Okay, third column, evaluate the value of this delta. Okay, and how are we going to do that? The third column, if you take a look at this, is the third column, right? So let's find the cofactors of elements of the third column, right? So we have C, first row and third column, C13. This is the element, okay, C13, and what's the cofactor? This will be minus 1 power 1 plus 3 times the determinant formed by removing this row and this column, that is 1 y 1 z. What is the value? What you'll get is minus 1 power 4, which is actually plus, and this will be z minus y. Okay, this is what you'll get, z minus y. What next? C13 is done. Next you'll have C23, the third column. That's what you're interested in, third column, right? And C23 will be minus 1 power 2 plus 3. Okay, determinant obtained by removing the second row and the third column, you get 1x 1z. Okay, 1x 1 and z. This is what I will get. Is that okay? Yes. This will be equal to what? This will be equal to minus 1 power 5, which is minus, and what you'll get is z minus x. Okay, that's okay. Next, if this is minus of z minus x, this will convert to x minus z, as you can clearly observe. That's simple. C33 is the next element, which will be minus 1 power 3 plus 3 times determinant formed by removing the third row, third column. What is that? 1x 1y. This will be equal to, if you observe, 1 power 6 is plus y minus x, as you can observe. Y minus x is what I'll get. Is that okay? Yes. So therefore delta will be equal to what? Along the third column, the first element will be A13 times C13 plus A23 times C23 plus A33 times C33. This is the value of the determinant. That is multiplying sum of products of elements with their corresponding cofactors of any row or any column is equal to the value of determinant. Right. A13 is yz. Okay. And what do we have? Z minus y along with that. Okay. What next? Next you have zx. So plus zx times you have x minus z. Okay. Plus you have xy times y minus x actually. This is what you have. This is what you can have, as you can clearly observe. Yz times z minus y plus zx times x minus z plus xy times y minus x is what we have over here. Now, although this particular result seems okay, that we have found the value of this determinant, but do you recall this is some kind of a circulant, right? Some kind of a circulant, and the value will be some kind of a circulant, some kind of a circular type of value only. The output would be, if you replace, let us say, x and y, if you interchange, you will get two particular rows same, therefore x minus y should be a factor over here. Oh, what are you talking about? I'm talking about something interesting which will happen on simplification of this. Let's try to simplify this and try to bring out factors from here. What are the factors? Okay, what do we observe? I observe a z minus y over here. Let it remain as it is. This is yz times z minus y, but let's multiply these other terms together. So what do I have? I have a zx square, which can be written as x square z. I have a zx into z, which is xz square with a minus. Then I have a xyy, which is xy square with a plus. And I have xy times minus x, which is minus of x square y. Okay, minus x square y. This is what I have. Observe, we are interested in this z minus y somehow, and when I see this x square z and I see x square y, I get a z minus y over there. Right, a z minus y is being created over there. Similarly, if you observe these two terms, can you take out a x common from here, and do you observe that z square minus y square will be formed over there? Let's see. Let's write one more step, yz times z minus y plus, from this and this term, I'll take out x square common, I'll get z minus y, and I'll take a x common from here. What I'll get is z square minus y square in the bracket over here. This is what I'll be getting. And now the three terms that you have, this has a z minus y, this has a z minus y, this has a z minus y for us. Let's bring that out. Z minus y. What remains in the bracket is yz plus x square and minus x times, this is z square minus y square. It was having a z minus y. It also had a z plus y. This is what we had. Right. Is that okay? Yes. Continuing further, what else? Now x square minus xz minus xy is what I have, and can I take out another similar factor somehow? Yes, maybe z minus y is okay. This can be simplified as yz, let it remain as it is, plus x square minus xz minus xy is what I have, and beyond that we'll solve and write things over here. Let me get rid of this thing, these few steps. Cofactors, the value of cofactors not required anymore. Let me get rid of this. And then we'll see what else can be done over here. Okay? Yes. So the next step after that, the value of delta that we are interested in will be equal to, therefore delta is equal to what? Z minus y is okay. Okay, and in the bracket, in the other bracket that you have, I observe that I have a x square and I have a xz. Let's take a x common from here and you get x minus z. Okay. The other two terms, yz and xy. Do you observe that the factor of y can come out common? Y times z minus x is what I have. Can you observe that? Yes. The important thing, this is x minus z, this is z. Okay. I can take out another minus common from here, and what will be formed over here is x minus z. Can I take out a factor of x minus z common? Yes. This is z minus y times x minus z, and what remains is x. There was a minus extra coming out from here. This is x minus y. Let's rearrange a bit, and if you observe, yes, this has taken the required form, x minus y. Okay, this is z minus y, y minus z. There will be an extra minus. Let's give that over here, and this will be z minus x. And that here is the final answer of this question, as you can clearly observe. Now, when you solve a similar question using properties, that is, by creating zeros, by subtracting these ones, you will get a factor of x minus y, y minus z directly, and the other factor z minus x, the third factor z minus x, can be obtained very easily. This is the form that you will get very easily. Herein, when we use this approach, oh, did we get something wrong over here? No, we did not get anything wrong. Is this approach lengthier always? No, I'm not saying any of those things, that this approach is lengthier always, but in this particular question, in such circulant type questions, the better approach is to use properties and simplify and create some factors, and on the basis of that you can get this version directly. Otherwise you will get this version directly, and then you will have to simplify in a similar manner, right? And that simplification is also possible when you have an inkling that yes, something is amiss over here, and this particular expression, okay, this particular expression does not look very nice. We can simplify it further. That is something that you should be having an inkling of, and after that, yes, obviously you can attempt the question easily, right? Keeping this in mind, that's all in this question. Let me get aside for a bit to take a look, for you to take a look, right?